Okay, so we're going to continue with chapter 3. We're on 3.2 and moving on to 3.3. Both sections are very similar. They're going to deal with exponent laws. So we're going to be dealing with like simplifying exponents, multiplying exponents, dividing, product rule, all that kind of stuff. Um, or section 3.2, we're going to go talk about integral exponents. So integral exponents are exponents with that are whole numbers, not fractions. And then the second part in 3.3 is rational exponents, which the exponents could be fractions there. So let's jump into it. Okay. So learning target to relate rational exponents and radicals. Okay, toolkit taking square roots and cube roots. We just learned in section 3.1, so we should be okay with that. Converting decimals to fractions and order of operations. So this kind of stuff we should already know how to do BEDMAS. But yeah. Yeah, so what is an exponent? An exponent tells us how many times we are multiplying the base by itself. So for example, 2 to the power of 4. So we can say 2 to the power of 4 to the exponent 4, but is basically just 2 times 2 times 2 times 2. And these little dots just mean multiply. A different way to write multiply. There you go. Okay. What about negative signs with the base? Okay, so there's a negative sign there. So if the negative sign is inside the brackets with a base, we need to include it in our multiplications. Otherwise, leave it out in the front. So an example is here. This is negative 5 to the power of 2 in the brackets. So this is going to be negative 5, right? So once. And then we're going to multiply it again. So times negative 5. Okay. So negative 5 multiplied by negative 5 equals 25 because a negative and a negative make a positive, right? All right. What about if it's not inside the brackets? So that means it's only going to get applied one time here. So negative 5 multiplied by 5, which is negative 25, right? Negative times positive. So there's a difference. They look the same, but the answers are different because of the brackets. Okay, exponent laws. Okay, the first kind of idea we're going to look at is exponents of 0 and 1. So this is something you just need to memorize. And let me just move this up. Okay. So anything to the power of 0 simply is just going to be 1, right? A number, so any number integer to the power of 1 is going to be just itself, 5. So pretty straightforward. Reviewing product rule here. So right here's a general rule. A to the m multiplied by a to the n is equal to a m plus n. So we have our base a. So when you have the same base here, a and a, you can simply just add the exponents when you're multiplying. So here we got the same base, 4 and 4. So simply we can just multiply 4 and 4. So this is the same thing as 4, 3 plus 4. And again, that's just applying the product rule. I'm just adding them because they're multiplying. So we got 4 to the power of 7 here. Okay. Second part, we got x to the power of 6 and x to the power of 10. So notice we have the same base. So simply we can just write down x to the power of 6 plus 10, right? Because the base is the same. And we got x to the power of 16. Okay, pretty straightforward. Okay, let's go to the next page. Okay, so the quotient rule here. So when you have the same base, x here, and you're subtracting, you're going to subtract the exponent when you're dividing like this. So x to the power m and divided by x to the power n is simply the m subtracted by the n. So let's take a look at that. So here we got, there's not a lot of space here. Negative 4 is the base, and to the power of 5, negative 4 to the power of 2. So simply here we can write down the base, negative 4, to the power of 5 minus whatever this is. So minus 2, which equals negative 4 to the power of 3, right? 5 minus 2. Okay, let's try it again. So x6 divided by x. So remember, if there's nothing here, it's just an invisible 1. So you can even write down there's a 1 here. And this is just the same thing as this, just written in a different way. So we can write down x to the power of 6 minus the 1 because they're subtracting, and we get x to the power of 5. Okay, good. So let's go to, okay, the power rule here. When you have an exponent to another exponent, so a power to a power, you're simply just going to multiply them. So here's represented by variables m and n. So let's look at a couple examples. So 3 to the power of 5 to the power of 4 is simply going to be 3 to the power of 5 times power of 4. So that's the same thing as 3 to the power of 20, right? Okay, so let's look at this one. Same idea here. So power to a power. So you know the rule is going to be multiply. So x 8 times 2. So you got equals x to the power of 16. Okay, sweet. Okay, let's look at the quotient rule. Okay. Okay, so a product to a power, same sort of idea. So when you have a couple bases in here, you can just distribute the integer inside so that the integer goes to the b and it goes to the a here. So so let's take a look. So simplify 3x 3x to the power of 3. So you can just write it simply 3 to the power of 3, x to the power of 3. And then you can't really do the x anymore. You have to leave it x to the power of 3. But here we can do 3 cubed is 27, x to the power of 3. Okay. Here do the same thing. So distribute the exponent inside to each variable or coefficient. So here I'm putting the 4 onto everything inside. So here the variables you have to leave. 2 to the power of 4 is going to be 2 times 2, which is 4 times 2 is 8 times 2 is 16. Okay. Okay, good. So power to a fraction to a power, same idea. It's just a fraction now. So just put the n onto the a, put it onto the b. There we go. So an example there. So let's take a look. So you can rewrite this as, let me write 4 over 5, and the 3 goes to the 4, also goes to the 5. And we can write this out again. So get 4 times 4 times 4, 64. And 5 times 5 times 5, 125. Okay. Same idea here. So let me just write it out like this. The 4 goes to the top and the bottom. And this is a y, not a 4. And that's all we can do. Okay, good. Next page. Okay, powers with the exponents, the numerator of 1. So over here, numerator 1, your base. And this n here is your root. Okay, and in this case, we're talking only about natural numbers. So we're not going to look at fractions in a fraction or anything like that. Fractional exponents, rewriting powers in radical form and exponent form. So let's look at this. So we got 1,000 to the power of 1/3. So what you're going to do is you just take the root, the bottom number, and you swing it over here. Okay, I'll kind of show you it makes sense. And the 1 here just stays as a power. Okay, so for example, this swings around here and we put in as a radical, so 1,000. And the 3 goes on to this side here. Okay. And the 1 is on here still, but we don't need to write the 1. It's like an invisible 1. So there we go. So this is basically saying the cube root of 1,000. So what number times this multiplied by itself gives 1,000? So you should know it's going to be 10. So 10 times 10 times 10 is 1,000. Okay, so let's try that again. So 25 to the power of a half. It might be helpful to write the decimal as a fraction. So 0.5 is the same thing as 1 over 2. And now the same thing. We're going to swing the 2 over and put it as a radical. So, and we're going to go over radicals in more detail in section 3.4. Okay, there you go. So this is what's the square root of 25? Usually you don't have the 2 here. So usually it's just written like that. And then it just implies that we're finding the square root. But here we have it written down. And you know that 5 times 5 is 25. Okay, so let's try this one here. So again, you're just going to swing the bottom onto the outside here. So we got 1/3, 8 to the power of 1/3. So let's put the negative 8 inside the radical first. And again, the root swings to the outside. And that's pretty much it. So it's asking us what multiplied itself 3 times gives us 8. And you know that negative 2 times negative 2 times negative 2 gives you 8. All right. So here it looks a little bit more complicated. Hopefully you can see it, but on here, but you can see it better on the notes I uploaded online. But the exponent's going to go to both the numerator. Numerator is the top value, and denominator is the bottom value. So let's rewrite this. So the top value will be 16 to the power of 1/4, and 81 to the power of 1/4, right? And then simply we swing the 4 onto the outside again, the root, and we put them in radical. Might run out of room here, but write it out neater on the notes. Okay, there we go. So now it's asking us what number multiplied by itself 4 times will give us 16. And you should know it's going to be 2, I believe. 2. Oops. And then underneath, what number multiplied by itself gives us 81? So I think 3 times 3 times 3 times 3 gives us 81. 9, 19, 18, 27, 27. Yeah, okay. Okay. Okay, so next case, example, power with rational exponents when m and n are natural numbers and x is a rational number. So same sort of idea, the examples that we just did, but now m is going to be a number greater than 1 in this case. So let's look at this. What are we going to do? Again, swing the bottom number, the root, to the outside and put it as a radical. So it's going to be 26 to the 5, right? And then this number here, the power of 2, is going to stay out there. And then we can just put everything in a bracket. So that's all it is. Yeah. We'll do that, the same sort of thing again. So I wonder if the light will help here, make it brighter. Okay, that might be better. And I'll raise it up a bit. Okay, so 25 to the power of 3/2. What you're going to do, again, swing the 2 out. So put the 25 as a radical, swing the 2 outside here. And I'm not going to put it this time because if it's nothing here, it's an invisible 2. So just so you get used to it, and I can put the 3 on the outside. There you go. Okay. All right, so let's look at example 3. Oh, before we do that, just remember in this form, x to the power mn. The top is the power, the bottom is the root. Again, so you can see the n gets swung out to the outside, the m stays there on the outside, the power. So write the following in exponent form. Okay, now we're going to do it backwards, going the other way. So here we're going to swing this back over here. So what's here right now? There's nothing there. That means there's a 2, right? Invisible 2. So simply, this is going to be 6 5/2, right? 6 to the power 5/2. Okay. So remember that. If there's nothing there, there's invisible 2. Okay, here again, same sort of thing. We're just going to swing the 4. Pretty straightforward. And we take off the radical sign. So 3/4. Yeah, nice. Okay, let's do number 4 here. Okay, so these questions are looking a little bit trickier, I guess. So this is 100 to the power of 3/2. So again, to evaluate this one, I'm going to put it as a radical first, 100, and this whole thing, remember, put in the bracket, and then over power of 3 is left over the power, 100. And now what are we going to do here? Bed mass, right? So do what's inside the brackets first. So square root of 100 is 10. So we can write that out. Equals 10. And then 3 is still outside. 10 to the power of 3. So what's 10 to the power of 3? You just add the zeros. So 10 times 10 is 100 times 10 is 1,000, right? Okay, there we go. All right, so next question here. Here, again, I'm going to put it in radical form first. So negative 27 inside. The root goes on to the outside, and put this whole thing in brackets. Okay, so what number multiplied by itself 3 times gives you 27? So negative 3 times negative 3 times negative 3. So it'll be negative 3 to the power of 4. And then what's negative 3 to the power of 4? Negative 3 times negative 3 times negative 3 times negative 3 is going to be 81. So you could do that part on your calculator, or you could just write it out and do it. Okay, so last question here on this page. So put it into radical form first. 32, 5 gets swung over. Put it all in brackets to the power of 4. So what number multiplied by itself 5 times will give you 32. And then here, you know, it's going to be 2 times 2 times 2 times 2 times 2. So it's going to be 2. Okay. And then still to the power of 4. So what's 2 to the power of 4? So 2 times 2 times 2 times 2 times 2 equals the 16. Okay. Okay.